Hello, welcome to this video. In this video, I'm going to show you an example about sampling distribution for the mean, for sample mean. So let's look at a classical question like in Stats 211. This question says that assume that the duration of human pregnancies can be described by a normal model with mean 264 days and standard deviation 19 days. And what percent of pregnancies should last between 265 and 270? So you're going to find the percent between two numbers, and this is a normal model with mean this many and standard deviation this many. So you can simply open up the normal calculator from Stats Calculator and normal. Type in the mean 264 and 19. And now it says between two numbers, you're going to go to between and type in the two number 265 and 270. 270, and this is the it gives you the proportion within this two number. This question asks for round to one decimal, and it's in percent. So we're going to time this number by 100. We will get 10.3. 10.3%. At least how many days should the longest 20% of all the pregnancies last? So now we are looking for a standard because only one number. Okay, and now before it gave you number, you find the percent, and now it gave you percent, you need to find a number. So when you go to stats and it says the highest 20%, you can change this to x greater than. It says the highest 20%, you're going to put 0.2. Actually, this also gave you some hints, right? Type in 0.2 and greater sign, you find this number. Okay, that's what you need to do and just compute, and this is the number you are looking for. That will be one decimal. Let's see, this will be 280. One decimal, look at the second one, it's 9, so add up 1 to the first one is 10, and so this becomes 0, and this one's 9 plus 1 is also 0, but the second one is 8, so that's why I get 280. And now the question comes to the sampling distribution for the mean now. Suppose that you have 90 pregnant women. Let's let X bar represent the mean length of their pregnancy. According to the central limit theorem, what is the mean and standard deviation of the normal model of the distribution for the sample mean? So this basically tells you that you're going to find a normal model for the mean, okay, for the mean duration. So according to central limit theorem, we say that if the original model is normal, then the mean also has a normal distribution with the same mean as before. So you're going to keep this mean. So your mean is the same as before, but standard deviation of the mean is going to be scaled by using the original standard deviation divided by the square root of sample size. So let's do that. Original so we're going to do square root of 19. Sorry, my first time to use this. Square root of 19. So that's our that's the square root of 19, because I'm going to divide that number by 19. So I'm going to inverse that. Okay, pardon me. I wanna find a way to do this. Okay, let's use another calculator that I'm more comfortable with. Delete those. Don't need those numbers. Okay, ignore those numbers. It's not relevant here. But now I want to use equal. Right, I don't know why it won't let me do anything. How about open a new calculator? It's still not working for me. Okay, I open new calculator here. So I want to use 19 divided by the square root of the sample size. Sample size which they tell you that is 90 pregnant women. So you can do 90. And I should be good. So this is the standard deviation and says run to 2 decimals. So that's going to be just 2, right? And then the mean has a normal distribution with mean less many and standard deviation 2. So what is the probability that the mean is less than that? So when you go to StatCrunch, so you're going to find the normal model for the mean. As we find before, the mean doesn't change, but our standard deviation changed to 2. And now you want to find the mean is less than 267. So you can change that to less than 267. We compute. This is our probability. So run to 3 decimals. 3 decimals that will be 0.933. 0.933. So let's check our answer. Yes, your input is correct. Okay. So this is how you do this central limit theorem, like sampling distribution for sample mean. And I will have another example coming next. Here is another classical question about sampling distribution for the sample mean. So here it says a waiter believes the distribution of his tip has a model that is slightly skewed to the right, with a mean this many and standard deviation this many. He usually waits on about 50 parties over a weekend of work. So estimate the probability that he will earn at least 550, like for the 50 parties. So this question actually from the total, right? You're gonna find the total of his tip greater than 555. What's the probability? So we don't know the distribution for this 50 parties. Since we're talking about sampling distribution, we can talk about the mean. So this question is equivalent to, like, what is the probability that the average tip is greater than, because you do average tip, so you're going to divide this 550 by 50, right? So let's do that, see what we get. So this is just a calculator. You can put this in your calculator and see what you get. So I get 11. So this question just equivalent to ask you to the probability, like what is the average tip, the probability that the average tip greater than 11. So we know that the tip has a mean of this many and standard deviation, and the sample size is 50. And because the sample size 50 is greater than 30, so the mean of the average tip gonna have a normal model. So for this average tip, the distribution for the average tip will have a mean to the original one, and the standard deviation is the original standard deviation is 6.3 divided by square root of the sample size, which is 50. So we get the standard deviation and the mean for the average tip. So once we get those information, we can come to StatCrunch, type in our means. It's 9.7, standard deviation is 0.890955, and says we want the average greater than 11, so we're going to do greater than 11. To compute, that's our probability. So it says 4 decimals, that's going to be 0.0723. 0.0723. And the total amount she earns on the best 50. So you're going to do the best 0.5%. Compute, you get this number because it's 50. So 50 parties. This is for one party. So you can use this number 2 times 50. Okay. Let's use that number times 50. And we get this is the he will earn. Okay. 2 decimals, so we're going to keep that to that and check our answers. Yeah, that's correct. So this is how you solve this problem, for the sampling distribution for the mean. This problem is kind of hard, especially the second one. When we're using the model, we get the highest 5% for one party, but we have 50. That's why we multiply this number by 50. Okay, so I hope you learned something from this video.